attention now? Okay. You guys remember function notation? Back from Algebra 1. Okay, it says, remember I would have just a real simple equation, say y equals x plus 2. Okay, and then we would have to solve that equation given a value, or we would solve for the x. But if we wanted to give you a value, we would have to say solve when x equals 3. Well, we mathematicians really hate to write anything out because we suck at English. So we replace the y with f of x. And instead of writing out solve when x is 3, we would just put what's the f of 3. And what did you guys do in Algebra 1? You would just plug in the value 3 for x. So the f of 3 equals 5. That is what we call function notation. Right, Dave? Okay. Now, we're going to do function notation. Yes, sir. Yes, I am. Thank you. We're going to do the same exact thing to piecewise functions, except these are pieces of functions, okay? And the first one, we have two pieces. We have domain restrictions on these. Remember, we choose the x and solve for y, correct? Oh, what did I say? Domain restrictions. What did I say about English? Okay, so I have a choice of which one to use, and it all depends on what I choose for x. For instance, in number 1, what did I choose for x? Well, the number 10, right? We chose the number 10, or somebody did. And it says evaluate the f function when the x is 10. So you have to look at your domain restrictions to figure out which algebraic expression to solve or evaluate. All right, so the f of 10, we use this 3x minus 1 if x is less than or equal to 4, or we're to use 2x plus 7 if x is greater than 4. So which one are we going to use? The 2x plus 7 because 10 is greater than 4. Then we just substitute in 10 for x. And the f of 10 equals what? Wonderful. See how easy that is? Piecewise functions. The only thing we have to do is graph them and we'll be done. Huh? They're not this easy always, right? In math, things get harder and harder. More and more complicated. That's what makes it so fun. What? Well, just think of this as a big water slide, or if you really hate math, think of it as waterboarding. All right, f of 4. F of 4. Which algebraic expression do I evaluate? 3x minus 2 because this is x is less than or equal to 4, so we use 3x minus 1. Sorry, not 2, 1. So we're going to substitute in 4 for x. Okay, 12 minus 1 equals, look at that, the f of 4 equals 11. Okay, what about when my x is negative 2? Which one am I going to use? Negative 2 is less than 4, so we got to use the top one. 3x minus 1. Then we substitute in negative 2 for x. So I have 3 times negative 2 minus 1. Negative 6 minus 1. Negative 7. This is our restrictions. We have to follow this. I chose our x is negative 2, right? Negative 2 equals x. So I look at here and say, what does negative 2, which one of these makes it true? Negative 2, is negative 2 less than or equal to 4? Yes. So I have to use 3x minus 1. What about 5 halves? Is 5 halves less than or equal to 4? What's 5? How about make that a decimal? 2.5, right? 2.5. Is that less than or equal to 4? Yes, we have to use the top one, right? You scare me sometimes. Okay, our x is 5 halves. Okay, so the rest stays the same. 3 times 5 halves minus 1. Oh no, here we go again, fractions. Oh my gosh, not only that, not only do I have to multiply it, but then I have to subtract from a fraction. I'm screwed. Okay, 3 times 5 halves, 15 halves, minus 1. Okay, this is 7.5 minus 1 is 6.5 or 13 halves or 6.5. I don't care what you use. Um, 1 is the same, is equivalent to 2 over 2, right? 15 minus 2, 13. All right, easy peasy, right? Okay, look at the next line, group of problems here. We have 3 different functions, correct? Not only do we have 3 different functions, we have 3 different piecewise functions. Okay. So when we're looking for the function variable, it says find the f of 2, so I have to use the f function. Okay. So the first one, I'm going to, my x is 2. Is x less than or equal to 0? Is 2 less than or equal to 0? No, so I have to use the bottom expression. So the f of 2 equals 2. Nothing to solve for. Gives us a value already. Nope. The f of negative 4. Negative 4 is less than or equal to 0, so its value is 3. The f of 0 is 3. The f of 1/2 is 2. It's greater than 0. What about the g of 7? Now we're looking at the g function. My restrictions is x is less than or equal to 3, use this expression. If x is greater than 3, use this expression. So we have 2, our x is 7 minus 1, so it equals 13. Does anyone not see how I'm getting these? Okay. G of 0. 0 is less than or equal to 3, so I have to use x plus 5. Substitute in 0 for x, just fine. How about the g of -1? -1 is less than or equal to 3, so I have to use x plus 5. I'm substituting in -1 for x, so -1 plus 5, 4. What about the g of 3? X plus 5 again, right? Plug in 3 for x, so it equals 8. Okay, what about the h function? H of -4. -4 is less than or equal to -2, so I use the top one. So I have 1/2 x minus 4, and I'm substituting in -4 for x. So what's half of -4? -2 minus 4, -6. See how these get a little bit more difficult? All right, -2. -2 is less than or equal to -2, so I have to use the top one. 1/2 x minus 4. My x is -2 this time. Half of -2 is minus 4. Bless you. And let's do 12. 6 is greater than -2, so I have to use the bottom one. 3 minus 2x. Substituting in 6 for x. So 3 minus 12, which is -9. Now the fun stuff starts. We have to graph these. Are you ready? Ready to really have some fun? Are you ready, kids? Where's that from? No. Yeah, it is a SpongeBob. Yes, it is. It is SpongeBob. Are you ready, kids? There's a comedian that makes fun of that. I can't remember. All right. So here's what we're going to do. Now, these are pretty, believe it or not, these are pretty simple because we only have 2 pieces of the function. There's only 2 of them. Okay, so I look at the domain restrictions here. Here's our domain restrictions. No, we're not going to insert the paragraph, which would be the line y equals x in this case. All right. Okay, there's domain restrictions. So we have numbers that are less than 1 and equal to 1, and we have numbers greater than 1 on the x-axis, correct? So I'm going to put a boundary line here at x equal 1. Okay, here's x equal 1. It's a boundary line. Half of our numbers or whatever, this line is going to represent this number, and this line is going to represent those numbers. Okay, well, we need what? These are definitely lines. They're in y equals mx plus b form, right? So let's, how many points do I need to graph a line? I need to find 2 points. Guess what I'm going to use? my handy-dandy t-shirts. I need at least 2 points. Okay, the first point I'm always going to use is that boundary line point. Okay, I am choosing 1 for x. I have to put it in there, plug it in, so 2 times 1 minus 1 to get my y. 2 minus 1 is 1. I'm going to choose another point. We can choose 4. Now, is 4 going to work? No, because it has to be less than 1. So let's use 0. Yes, ma'am. Any points you want. As long as it's in the domain. Yes, yes. This one has to be less than 1. This one has to be equal to and or greater than. We're always going to use this point for a starting point in our t-shirt. Yeah. It doesn't, when we're doing our charts, you always want to start with 1, the boundary point. Okay, if I plug in 0, I get 0 minus 1 is negative 1. So there's 2 points I'm going to make my line. So I have 1, 1, and 0, negative 1. So here's my line for this one. You with me? Okay, now I'm going to find out where this line is. So I need to make a t-chart for that one. X, Y. I always want to choose my boundary point for my X. So I have 3 times 1 is what? Plus 1? Okay, choose another point in the domain. Don't be a jerk. Don't be a jerk. Let's use 2. 2 times 3 is what? Plus 1? Two times 3 is 6, plus 1 is 7. So I have 1, 4, and 2, 7. So there's my second piece to this piecewise function. Now, the only thing is we have to figure out what to do with that boundary line, those points, right? Which one of these expressions include the 1? No, there's only one of them that includes it, the top one, which was this green line, right? So we're going to make sure we put a big old closed circle at that one and an open circle here on the other one. And this, my friends, is graphing piecewise functions. For lines, yeah, that's all you need is 2 points. Okay, the equal sign. This equation includes the point 1, and that's this equation. Say that again? Yeah, wherever the equal sign is. It's closed. Wherever it's not, it's open. Yes. You'll never see this or use this again in your entire life. About as serious as every time you ask that question. No, I mean, all right, number 14. Okay, where's my boundary line? 1. So here's x equal 1. Okay, let's make a couple of charts. See of x, y. Again, these look to be lines, so I really only have to do 2 points. Always use your boundary line point, 1. If I plug in 1 here, what do I get for y? 1/2. I'm going to use a smaller number than 0. How about -2? Okay, -2 times 1/2 is -1. You see why I chose -2? Because I get a whole number. Okay, so I get 1 and 1/2 and -2, -1. Okay, check the other one. See, of x, y. My boundary point there is 1. If I plug in 1 here, what do I get for y? -1 plus 3, 2. Pick another number greater than 1.
4.
-4 plus 3 is -1. So I have 1, 2, and 4, -1. Okay, which one has the closed circle? Which one has a closed circle? Which one has a closed circle? The bottom one, right? This guy here has a closed circle because of the equal sign. Which means top one has to open. What? Who, just now? I wasn't listening to her. I don't know what she said. Sheet 17. What's my boundary line? X equals 0. So it's the y-axis. That's x equals 0 is my boundary line. Okay, I need 2 charts. Start with the boundary line limit, which is 0. If 0 is great, I think the greater sign's up with the top one. So if I plug in 0 for x, what do I get? 0. I need a number smaller than 0. How about -1? -4. -4 is less than or equal to 0. -4 is +4. There's 2 points. 0, 0. By the way, is this an open or closed point? And then I have -4, 4. And I need a t-chart for the other. Always start with your boundary point, which is 0. 2 times 0 is, pick another point greater than 0. 3. 3 times 2 is, so I have 0, 0. And 3, 6. By the way, what's the domain for this piecewise function? If I asked you for the domain and range, could you do it? Yes, domain would be -infinity to infinity. What would be your range? 0, including 0 to? Good. What about the previous? Yes, ma'am. whatever is making up that boundary line. Yes. Let's look at the domain and ranges of the other one. What? Yeah. Okay. So if I put an open circle here, you could put an open circle there, but because it's closed, it doesn't really matter. Because it includes the point in the other one. Okay, let's take a look at the domain and ranges of the ones we did. Almost done here, guys. What's my domain here? We don't really do domains and ranges for Piecewise, but that's okay. My domain is what? What's my smallest x number for this piecewise function? Negative infinity, positive infinity. Do you see a pattern here? No, you don't have to. Yeah, they're both negative and positive. All right, so where it says evaluate the following, well, first you have to graph this. Okay. Then it says evaluate the following. We could just evaluate this off of the functions up here, or you can do it on the graph. Let's just do it off of the functions. The f of 0, well, 0 equals 0, so it's going to be the bottom one, 3 minus x, because it's equal to 0. Okay. I have 3 minus 0, which is 3. Negative 3, I'm going to use the top one. I get negative 6 plus 3 is negative 3. And the f of 2 is greater than 0, so I have to use the bottom. 3 minus 2 equals 1. Now, look at number 2. Look at our domain restrictions here. Okay, we no longer have two boundary lines. One boundary line. We have two boundary lines. What are our boundary lines here? X equals 0 and x equals 2. So here's our boundary lines. X equals 0. It tells us where the domains switch. Okay. Actually, yeah, where the domain and ranges actually switch. X equals 2 is the other one. So here's 2. Okay. So here's our 2. If you guys have colored pencils or highlighters, this is really a good section to start using them. All right. We got to make some t-shirts, right? Okay. For the first one, I'm going to make a t-shirt, X, Y. I'm going to use the 0 for X. 0 plus 3 is 3. I need a smaller number than 0. I'm going to spread it out just a little bit and use negative 2. Negative 2 plus 3, positive 1. Okay, do we include the 0 on this one? We're including the 0, so it's going to be a closed circle. So 0, 3 with a closed circle. And I have negative 2, 1. So there's that line. You with me? Okay, the next restriction. Okay, I still have to make a chart. I have to make my XY chart. My X, this time I'm going to pick my two boundary points. I'm going to pick my two boundary points. I'm going to pick 0 for X. What's Y? If I pick 0 for X, what's my Y? 3. If I pick 2 for X, what's my Y? 2. Now, which one of these are going to be closed? No, it's going to be the 2. Okay? This is the one that's going to have a closed circle because it has the equal sign. So I have 0, 3, and 2, 2. 2, 2. So here's the second part. Open circle. Pardon me? Yeah, how did I get 2? This should be 3. And it gets an open circle, right? Yeah. And then the last one. Let's see, if X, Y, I'm going to choose 2. I got 3. Then I'm going to choose 3 and get 5. And there's my graph. So, you guys should finish page, at least worksheet 1 tonight.